That one's recording audio as well.
Yeah, you weren't in the camera shot there when you did that. Cool, nice. Okay, so thanks everybody for coming, despite the fact that we said we were just giving a presentation. I know that can be a very daunting prospect, specifically after like the first 2 weeks of uni. You know, presentation rot. You're probably all like wanting to kill me. But this should be fun, and we're going to try and make this as fun as we can. And it's sort of got a lot of the key details that you'll want to hold on to if you're going to build a robot sort of going forwards. So we sort of just got to get it out of the way, unfortunately. But we're going to try and make it as good as possible. So without further ado, first off, why would you want to build a combat robot? I mean, you're all here, so I'm kind of hoping that you want to build a combat robot. But it's worth recapping. It's really fun. Like, you know, this might seem a little bit weird coming from these sort of two nerdy people at the front. Well, yes, robots. But in all seriousness, it's a really good thing to do. It's like very rewarding when things go right, and it's also very rewarding when things go wrong and you learn and then you make them go right afterwards as well. So I've got sort of there the community. Actually, I don't have it there. I did have it there, but it's not. The community of combat robotics is, in my opinion, one of the best sports communities I think you can get. Probably because it's, you know, like less sports, more engineering. But everybody's like super nice in it. I think it's the only community that I've seen where people sort of willingly come in, try out a load of stuff, chuck their robots in, it gets a bit broken, and then they come back like, oh, that was great, I'll do it again next time. You also get to learn new skills. Like the actual skills building here, I think is second to none. Apart from if you're doing one of those like 6-person teams where you're trying to build something. It's like a university thing, but those can get a little bit intense. This is a lot less intense. You learn CAD skills. Everybody within the society who's built their own robot, I'm pretty sure, knows how to use one CAD software to a reasonable degree of competency. I know a number of people who have gone on from the society and sort of just got a job doing CAD. I think, I know quite a few people who've done that. So that's great, that's always a plus. You also learn sort of electronics and software. You don't have to do this, if you don't want to, and it's sort of a little scary, but you definitely get exposure to it. And honestly, especially when it comes to electronics, which really at this level, unless you're building like a nuclear reactor, a lot of small electronics is very plug and play. And just getting that exposure to it is super useful, being able to confidently say, oh yeah, it's a battery, I just zip it in there and it works. You also get some good experience on physical construction for CNC things like 3D printers or mills or lathes if you have access to them. I'm not sure. We don't have any lathes in the iForge. Sadly not. Sadly no lathes. But physical things like that is super nice to be able to say that you've done some of, as well as obviously you get practice with hand tools. As you can see, our arena here was built sort of when we were all in our younger years of the Roboteers Society. Now, with however many years experience we have behind us, these lines would be cut a lot straighter because we know how to use saws now. And finally, you get experience driving the robots. This isn't really applicable to like the outside world. It's rare somebody's going to come up to you and be like, "Here, drive this robot." And you're going to be like, "Oh, okay." But it's super fun anyway, and it's sort of, I don't know. I guess I could spin it as developing spatial coordination, but it's cool. So, the first thing we're going to have to cover is the rules. Please bear with us, because this is like the driest part of this presentation. But it's really useful to know the context in which we're doing this. And it's also important for me to point out now that obviously we're the Roboteers Society, which means that we do just, we love general robotics. So if you're sat here thinking, wow, all of these rules are super constricting, and I'm not even sure if combat robots is a thing, then just go ahead and build like a whatever robot. Just build a chess-playing, 6-legged walking robot, just amalgamating things that people have presented here now. You know, if you want to do something more off the wall, then feel free to do that. But we, oh blimey, no, it's okay. Sorry, this laptop's got like a fiddly left button, I think. But yeah, we will be just talking today about Antweight combat robots and the explicit rules that go around that, just for if you want to get into that. So, primarily, we follow the Antweight World Series rules, which you can find at antweight.co.uk/rules.htm. I thought I had missed off an L, but no, it is .htm. This is because, like most people in the UK, in fact, I don't know anybody who doesn't follow these rules. So they're generally very well accepted if you end up going to any national events, or we get people from externally to come in here and fight alongside us who want to all be on the same rulebook. The most important thing of this is that everything's going to go off weirdly. The most important thing is that the robots have a size limit. They need to fit within a 4-inch cube box, which is 101.6 millimeters cubed. And they can get bigger once you've got them in the arena. You know, if you start off that big and you get it in, it like unfolds, takes the form of, Voltron sort of collection thing. But like it's a little constricted at the beginning, and you can't sort of have springs. You can't like just put it in and then the box comes out and it just like expands to the entire arena. Don't fill your robot with like expanding foam. That's not good on multiple accounts. And there are 3 clear categories, and then sort of one like weird category, and that is the rollers, walkers, and shufflers. A roller is anything with wheels, and this sort of comes in at 150 grams, so you get quite a decent amount of weight to play with there. Back again. Walkers, because you're doing something more complicated, you get an additional 75 grams of weight, putting it up to 225 grams. And shufflers are the same thing. Now you might be thinking that sounds a bit weird. To be honest, Antweight, the definition split between walkers and shufflers isn't very important. Basically, if we want to get technical, a walker has, I can't remember this off the top of my head, I think it's the actual legs have to move, or the rotating parts have to be rotating under 180 degrees, and then a shuffler is anything that like has its weight on its or on a large flat part, and also doesn't have wheels. But seeing as they both get you 225 grams, walkers and shufflers are generally used as interchangeable words at this level. And then there are cluster bots here. There's actually the rules here, apparently. This is going to get really dire, isn't it? Oh well. And cluster bots are sort of a combination of any set of robots. So they sort of follow this kind of simple little equation here for actually measuring the total weight of any walkers or rollers in them. So if you've got 2 rollers here, this is one of Robbie's clusters, round and round. They both have wheels, which means that in total they have to weigh 150 grams. Quite easy. But if one was a wheeled one was a shuffler or a walker, then there would be a little bit more leeway. But generally, if you're starting, you're probably not going to want to do that. So it's just something that we feel like we should say in case somebody, you're fighting your robot, somebody turns up with like 100 10-gram robots, and they're like, oh, this is great. And you're like, why are there 100 robots in there? Then finally, for safety, we mostly have to follow these shut-off rules. So we have to make sure that there's a switch visible on the robot, or this sort of removable link here. You can tell this is sort of actually, I think this link in particular just loops around there and then it plugs on the end. So if your robot's like on fire, you just unplug it or switch it off. You also have to have remote weapon deactivation. If you go to any event, ours or anything nationally, and are like, hey, here's my robot, you turn it on and then you can't turn it off remotely, they'll be like, that's not allowed. No. There's also like a weapon failsafe, so if you lose signal to your controller, the robot has to turn off itself. These are all sort of really basic things. Most of this stuff, apart from the link, is handled by any control configuration, but that's just something to bear in mind.
What is wrong with this presentation?
I don't know, I'm blaming your laptop.
There's nothing wrong with my laptop.
It's fine, we'll replace it in post. So, there are a few things that are banned, because everybody always wants to do at least one of these things. Fluid, glue, sticky things, that includes like, sticky back plastic, sort of just facing out your robot. That's banned. Obviously, there are some safety reasons around that. We don't want water and electrics, but also there are game reasons. It's kind of really boring if your robot just drives into the other robot and gets stuck to it, and then it's like you're just watching two bits of metal drive around in a circle. That's a bit pants. Entanglement is also one of those ones that's banned because it's kind of a bit pants. So if you've got just like a long piece of string and you're just like flailing it around, then you've just got two robots flailing around. Flames and explosives are banned because you don't want your arena and people being set on fire or exploded. Electricity or magnetic and inductive systems are also banned. You can't just electrocute the other robot or detonate an EMP and wipe out the other team and also every phone in the room, because that would be expensive and bad and you'd lose a lot of friends. Also, one that might trip you up is shatterable rotating weapons. So things like sanding blades or Dremel blades are quite often made of ceramics. We really don't want those to rev up to like 400 RPM and then split into 600 pieces and then just go everywhere, because it just sounds like the recipe for a splinter grenade or something. There are a few things that have limits as well. If you're doing any pneumatics or hydraulics, I can see you're all just dying to build some kind of pneumatic hydraulic thing, and you're all like experts in that area. So that's definitely going to happen. But if you do it, 100 psi is your limit. There are people who have like little tiny gas canisters, that sort of thing. There's also limits on deliberately detaching weapons. I believe this is mostly against things like projectile weaponry. That's sort of limited, but if you can fit it within a tether of 3 feet and just not use that tether to entangle people, then there's definitely that there. So, there's sort of varying degrees to which you can build a one-punch robot at this point. Sharp edges should really be covered outside of the arena. You have a little bit of sponge, preferably a bright color. And also batteries should be below 24 volts, no like 10,000 volt, you pick it up and you accidentally hit a ground wire and like your heart stops deal. No acid or electrolytes in them. You don't want like an axe to swing into it and then there's acid everywhere, and that would just be bad. And then, as I've already said, unfolding in the arena is allowed. If you've got your robot and it's smaller than the box, you put it in the arena, you press a button, it like origamis itself out. That's pretty cool. We'd love to see that. But it's got to be powered. You can't just like jack in a box.
I have a question.
Yes, go ahead.
Could it be like a latch systems where you like say wiggle the robot and then it would unfold at that point? Is that allowed, or does it have to be like attached specifically to the unfolding mechanism?
That's a very good question. I don't know if you have any press. I know that we've seen a robot that does that.
I'm thinking like Vex things where you'd like flip up a bit, you'd like shake and everything falls down.
It's probably pretty alright. Like as long as it wasn't like a pain to like reset it, like you put it in the box and then it's an actual top safe and you have to reset it.
Yeah, for reference, we've seen robots that are like spinners with like unfolding sort of blade things, and when they spin up, they unfold. Yeah.
What's it with electromagnets within the device? Does it count as being powered if you unpower the electromagnets and then it folds out?
That's a good. I mean, I imagine that sort of falls under the same kind of rules as like any kind of spring or like spring on a latch sort of thing.
I think we probably is not like.
I think we would probably like here personally. We would be more. I think we'd be accepting to that under our interpretation of the rules. Having said that, that is something that maybe different judges might look at and be like, So that's something you might want to consider if you're thinking about going into the wider community or any sort of national events. Yeah. Let's see if we can do this without spinning back. So so now we've done that. That's good. That's like all the boring safety stuff out of the way. We'll talk about actually how to fight. Now, when you're looking at these, don't think about, oh yeah, this is how a fight works. Mostly try to remember, if I'm building a robot, these are the things I want to beat it for. So like the fights are 3 minutes. Usually they won't last 3 minutes. They'll last like a minute. But if your robot runs out of battery 2.5 minutes in, you've lost. So that's sort of worthwhile, no? And they are usually run by 3 judges, certainly at proper competitions. Obviously, we sort of run skirmishes where maybe we're short on hands, but the general plan is you'd like to have 3 judges, and they judge in these 3 categories of aggression, control, and damage. Aggression is fairly obvious. If you're skirting around, actually like trying to punch the other robot in and not with your hands, with your robot, then you're doing well in the aggression side of things. Control is more how controlled you are over the fight. If you've got a robot that can grip and you're sort of controlling the area, if you're dominating that play space, then you're definitely getting points in that. However, as Rory sort of made it clear to me, some people might take control as like how much control you keep over your own robot. If your robot's just like spinning out of control and it happens to cover a lot of the play space, so no other robot can go in there, you're not getting control points because it's got to be sort of deliberate. You are in control of your robot. But that again is more down to the judge's discretion. And then finally, there's damage. That's obviously the most obvious. Usually, that will be decided by which robot stops first. But if your robot comes out with a giant like hole inside and the other robot's fine, then you're losing points in the damage. Oh, no, it's doing it again. Okay, there you go. Robbie, if you would like to take over, I will try to stop it from stolen.
So, yeah, I'm going to go through rules like how, I guess it's a bit weird how we're saying this, but it's how you lose a fight. So it's also how you win if you make your opponent do this. A robot will lose a fight if it is immobile for 10 or more seconds. So this can mean, like in the GIF, you've got Beanerino spinning and flipping over onto a face that it can't self-right from, so that will be counted out and then it will lose. Or if maybe a robot moves some of its drive and it can't move, but it's also, if it has to be able to, so it will get counted out if it can't drive out of its own circumference. So basically, if it's sort of just like twitching or can only sort of go in a circle, it'll probably get counted out. So you need to be able to continue driving to continue the fight. The next one is a robot will be out if it exits the arena. By the arena we mean the in this arena it's the wooden stuff. So if the basically the robot ends up in this circle getting flipped over or like smashed out of the arena, because we've got the box around it and it's normally quite close to the arena, robots can bounce off the wall and come back in, and in that case they normally stay in, but if they touch the floor they're out. But they can also, you see in the bottom right we've got like a bit with no barriers. If they get pushed out there, that's the same thing. And then similarly, most arenas have pits, so this is kind of the same as exiting the arena. So they fall in the pit. If they touch the floor, they're out. If one robot's pushing another robot and they both end up in the pits all at the same time, normally the aggressor wins, so the one doing the pushing.
Come on.
So the next one is tapping out. So if you're in a fight and your robot is getting just more and more damage and you just know you're going to lose, you can stop the fight and forfeit it, so you will say that you've lost, and it just means that your robot probably won't take as much damage, and it means like if you've got more fights in the competition, you won't have to spend as much time repairing it and things. The next rule is pinning, so you're allowed to pin another robot for up to 20 seconds. I think after 15 seconds a judge might start counting, just to warn you. This is just to keep the fights more interesting, so robots not just push another one up against for the whole fight. That's kind of boring. In America, I think you get points for pinning robots, but in the UK we don't really do that because it's boring. The next one are some sort of edge cases. So if two robots leave the arena at the same time, so not by pushing, but like in this example, some spinners have hit each other and like in a blink of an eye they're out. If judges or referees can't tell which one of them went out first, you reset or restart the fight. So you put both robots back in their starting positions in their current state, and then you resume the fight, and then, I don't know, one of them might be too damaged anyway and it will just get counted out. And then the last case is no contact knockout. So that's just for a robot to win a fight, the two robots have to make contact. It just saves if a robot accidentally just drives off the edge of the start and then you lose the fight. It's just so there's a bit of fight goes on.
Cool, so next up we'll cover the electronics, the actual basic stuff that you need to make the robot move. So, this is the electronics slide again. Stay. Okay. This is the basic electronics sort of layout. This is actually identical to what Robbie uses. Oh, no, this is it. Yeah, there we go. This is identical to what Robbie uses in his robot Life and Death that we'll have a look at closer a little bit later on. But generally, there are sort of 4 main parts, or 5 if you count the switch, main parts to a robot. That's, or to the inside of the robot anyway, that's the receiver, the battery, the power switch, and some kind of drive encoder or mechanism which actually converts the drive signal into power, called an ESC usually, and then the motors themselves. So the receiver here is, if anybody here is into like drone flying or hobbyist RC equipment, it's literally the same thing there. It's a device that takes radio signal from, in this case, a transmitter, which is, again, a drone or hobbyist RC transmitter, and it takes some power, and then it basically outputs the signal. So you move this stick up and down, the signal on one of these wires will go high or low, and it just sort of goes from a range of between 0 and whatever the voltage for that output signal is. This will then go into, or can go into what is called here an ESC, which is something that basically takes that drive signal and then turns it into actual power. So you can see here the power to the motors, there's sort of 2 on each, but then you've only got 2 going in. That's because what it's actually doing is taking in the power from here and just modulating it based on the signal that comes in from here. This stuff is like super easy to click together, and there are probably more guides than I can name you on the internet. And again, it's not just limited to combat robots. If you go online and search, how to combat robots, then you might come up with something similar like this. But if you also look at planes or drones, you'll see that they have very similar electrical properties as far as the actual setup's done. One thing to say here is that this design is simplified. This one in particular works with Robbie's layout because he knows that that works. But particularly things like the ESCs, they'll have voltage ratings on them. Some might be like designed for 3.3 to 5 volts, whereas the batteries that we use, which are 2S LiPos, generally output 7.4 volts. So if you're ever looking down a list, you make sure that you're trying to get the voltage that's right. If you don't have, if you're unsure, then drop a message in the Discord or through any of us. We'll be more than happy to have a look at the specs you've pulled up. But of course, this isn't the only thing you can do. If this was the only thing you knew, we'd have like really boring fights because they'd all just be wheels and robots. There are also variations. So the most minor variations is you can change it to a dual ESC from 2 ESCs. It's super advanced difference. Yeah, I know. It's crazy. These are just to make your life simpler. Instead of getting 2 of those things, you just get one board. It has much the same 2 signals coming in, transfers them to the drive motor outputs. Generally, people will go for these because they can be smaller than 2 individual boards. You can pack more into your robot. So they're going further down the interesting things. You can also start to add actual active things. So this is sort of a... Wait, it's gone away again. There we go. This is more of an active weapon system. So in order to make something like a flipper, you can use an external motor to this, which is different from those drive motors. So something like a servo is a kind of motor that can rotate between 0 and 180 degrees. Usually you get different servos that have different ranges. This is quite an interesting case actually, because it almost has its own sort of ESC within it. So you notice you basically just give it power and then a signal line directly. And then it will just take that signal, and if the signal 0 goes to 0 degrees, if the signal is 100%, it goes up to 180 degrees. Very easy to get going. The only thing that you might want to be careful about is sometimes these servos will usually be geared for sort of like 5 volts, and it can be difficult to get something that can handle a higher voltage. So you generally wouldn't want to go directly from the battery into the servo. So there we go. So I've added this little power regulator block there. So you can get like step-down converters or even just linear voltage regulators if you want to really go at it. Of course, you don't just have to do servos. There are other things. This is a brushless motor, very good at spinning very fast. The sort of things that are typically used on drones or on the props of model aeroplanes. This is the sort of thing that you'd put on a spinner. Obviously here we've got one of Robbie's spinners. It's got this blade here, but actually hidden in here is one of those brushless motors. I think it's very similar to this one actually, looking at the size of it.
I can see it there.
Oh yeah. This one's taken a bit of a beating, and you can actually see the brushless motor sort of here on the outside. We'll move these around so you guys can get a closer look towards the end. And we're back to the servos. Hey, come on, there we go. And that's really as complicated as it'll get if you follow this sort of plan. Of course, if you're more into electronics or programming and you've got experience with these things, or if you just want to and you feel like contacting any number of people who do in the society, you can also just shove an Arduino in there or any other microcontroller. Because these signals are fairly universally standard, there are a multitude of libraries online that you can just read off the values, and I believe that's what Dr. Flippy, your robot, does? Yeah.
So Dr. Flippy has a little, it's not an Arduino, but it's the same thing, so it's like a little square one. And then with that, we read in the signal from the receiver, and then also a switch, so we know what the position of the flipper arm is. And then with that, we can drive another ESC for the actual weapon motor.
So using something like an Arduino, if you have that experience, that can let you do some really creative things. For them, that means that they can more accurately control where their flipper is. There have been just a number of interesting sort of ideas. I've seen some omnidirectional robots that use this kind of thing to calculate directions of wheels, or things like daylight sensors, so you know when you're upside down, that sort of thing. Quite cool if you can get that sort of stuff in there, and we love to see that. Of course, making it more simple, and anybody who came to our BodgeBots event, we use the RoboPad, which are just sort of thought I'd take a slide to contextualize this. This basically fills the point of receiver and the ESCs for the drive motors. So you could still attach a weapon motor to it, but it just sort of unifies that. So what you were really doing there was just sort of working on a slightly simplified system. And of course, the difference here is that it uses a phone instead of a regular transmitter. So now Robbie's going to talk you through some of the different effects that choosing different weapons or motor systems can have.
So I guess, yeah, lots of robots have weapons and normally need an actuator to use the weapon. So I guess starting on the left, there's sort of simpler, easier ones. So the top, you've got two servos. The one on the left is like really common. Well, it's a common servo. It's a bit weak because it's got like plastic gears, and it will probably only run at 5 volts, so you'll need a regulator. But that's a really cheap, easy solution to get an actuator. So you could put make like a grabber or a weak sort of lifter, flipper, or potentially like an axe or something with one of those. Or you can get like metal gear versions. They're less likely to break as easily. It might have the same issues with like voltage, like supply voltage. But obviously those have like the built-in feedback. So you just send them a control signal and they'll move to whichever angle you tell it. Whereas if you don't need that, you could just use like a DC motor. So these are actually the same kind of motors you'd use for the drive, but you could have an axe on it, like a hammer, or I think your Dr. Flippy uses one with, I guess, your own limit switches in there. So I guess it's sort of similar to making your own servo, but obviously that motor would be a lot more powerful probably than the servo. And then on the right we've got brushless motors, which you normally use for spinning weapons. So all of these down here, which just have a big bar or disc that spins. You can either just bolt a bar directly onto it, although you have a high chance of damaging the motor, or you can have like a belt going to it or something, like belts and pulleys, or some people even use gears, but that's probably not necessary. And you get different sizes of motor, and they'll have different ratings depending on what you want. So, for example, in my cluster robot, I have a smaller brushless motor compared to this big spinner here. So you just get different sizes, different weights, different power. The smaller ones tend to run a lot faster, whereas bigger ones are a lot slower and have a higher torque. And then obviously you need, for all of them apart from the servos, you'll need some sort of, again, ESC, electronic speed controller, or a motor driver, same as drive basically. So a bit on the servo motors, so we said a fair amount already. So you've just got, they've got built-in feedback, so you just tell it a demand, it will just be a demand angle and it will go to it, which makes them really useful for An Antweight flippers, because you just really quickly tell it to go from like 0 to, I don't know, 90 degrees or something, and it will just quickly flick your flipper up. You can get different ratings of flippers, so some actuate a lot faster than others. So actually, the faster it moves, the better flip you'll normally get from it. But also they have different torque ratings as well. So like I've got 2 in this one, which is a bit excessive. So these are really fast servos, so it means that you can flip stuff really, really nicely. Another advantage of these ones is that they can run straight off a 2S battery, so I don't need a voltage regulator. Whereas some of the cheaper ones you would need a regulator, otherwise you'd probably fry the board. And yeah, I guess I'll just put a little diagram. You'll see that they have the 3 coloured wires on them. This is also for like, I guess most things, so other ESCs and so like brushless and brushed. Positive is pretty much always, this your plus volts is always in the centre, and then on either side you either have a black or brown wire, which is your ground, and then you'll have a signal wire, which is normally yellow or orange. Okay, yeah, so we know what we're doing. Yeah, so now to talk about chassis. So this is, so we talked about electronics. This is the physical bit of the robot. It holds everything together. Yeah, go on to the next slide. So, yeah, like I said before, it will hold your motors in place, your actuators, but then it also will need to protect your robot, so like armor and things. But yeah, I guess one thing is, what I've said there, you want it to be rigid in that some of the earlier versions of like this robot, when I had the weapon motor spinning, it created vibrations which made it sound like breaking itself. So I had to think about making it more rigid to support my weapon. And we've had, this has been around for quite a few years now, and we had at the activities fair the weapon motor mounts snapped because just overuse. So potentially, if this was going into full combat and you had like a big hit against it, your mounts could break. So you need to think about how strong your stuff is. But you can also make things flexible. So instead of just being so chunky that they don't break, you might use things like on here we've got polycarbonate, which is really good at absorbing impacts, as well as HDP, which just deforms rather than like cracks and breaks. Which I guess sort of goes on to the next bit, which is how you protect things. So again, you can either just have hard surfaces like maybe metal sheet. You can get like 0.5 mil titanium that some people like coat their robots in, or you can go the other approach, which like Blaze has done in blank C on the left, where he's got a TP bump so it's quite a soft spongy material to try and absorb the energy from the impact rather than deflect it. But yeah, you need to consider, I guess, where you're going to get attacked. Like a lot of robots have quite weak top armor because not many attacks come from above. Like this robot has 0.5 mil thick plastic, so it's basically nothing. Like you could get a scalpel blade and you could stab straight into the battery. But I feel I don't need it because I've got a big spinning bar, which means that that's going to hit them before they get close. Another thing to consider is, I guess, ease of assembly and disassembly. So obviously, most of the time to change the batteries, you have to take it apart. It can be a bit annoying to take some robots apart, so you think about that when you're designing the chassis. And also, once you've got your battery in there, you'll probably want to be able to, you have to be able to turn it off easily. So making the switch accessible or link. So normally just have like switch on a surface that won't get knocked easily. So like mine's on the back here, and it's away from the weapon as well. Then I guess the chassis can also form part of, I guess it's the robot's offensive capabilities as well. So I guess the most common thing of this would be a wedge, which you'll see on like most flippers and things. You want for a nice aggressive wedge, you have it like nice low angle to get under other robots. And also you can put like thin bits of plastic, acetate, to hug the ground, and that will get under other robots a lot easier as well. I guess also angles will help deflect hits, which is an advantage. So how would you make your robots? Well, I guess there's sort of two ways. A lot of Antweights are 3D printed, so you'll need to do CAD, which has its advantages. Like we can see here, you can quite easily improve them easily. Like you can quickly tweak the designs, and you can backtrack if you want, and maybe if your holes were the wrong sort of size, you can quickly increase them, print off a new one. This is the same because you've just got the file and you print it. The parts are easily replaced, so you can just print another one. You can easily make spares compared to a handcrafted one where you'd have to, by hand make each part. So I guess that might be slightly different. Yeah, I guess similar to 3D printing, there's just other forms of CNC machining. So this is like water jet cutting, or like routing and milling. So I guess this especially comes to do with like weapon bars. So like all of these have, I think this one's actually laser cut. You have CNC machined weapon bars, and like these are both exactly the same. So when one gets blunt, you can just swap it out for another one. You don't have to cut it by hand, which also really helps with making sure they're balanced. Because if they're unbalanced, you'll get loads of vibration. Whereas if CNC machine, it'll be nice and precise and balanced. So yeah, what can be more fun is handcrafting them. If you've got all the tools and like resources, you can quickly make them by hand because you don't have to spend ages designing it and then wait for it to print or be manufactured. You can just do things like this one, which is basically made out of a tin can. So you just get some tin snips, cut it up, just drill some holes. It's got a bit of polycarb, literally just a sheet, drill holes, put motors in it, and then it works. Like that's a lot quicker to do, and they can get a bit more beaten up. I mean, they'll get just as beaten up, but it's harder to, I guess, replace the parts because they're all done by hand. And yeah, I guess you can use other materials. Like I've said, you can just use stuff you've got lying around. I think that's that. So I guess I talked about this a bit already. But with a lot of the CNC produced robots, you'll need to do CAD first, which we've got a session next week, I think, on.
Do we have a next week? Yes, we think we do. Yeah. Okay.
Cool.
So, yeah, next week.
We've got a session next week where we'll go over how to use Fusion 360, which is what I've designed for all of my robots, bar this first one that I made in. So you just design your robot on the computer. So here you've got this flipper being designed. So you can see at the start it's quite basic. It's just a bit of material, and then I've just placed roughly where I want my components, and from there I've produced the design, bulked out, put a bit of armour on it and things. And then in the bottom you can see iterations from all of my spinners. So like going from, I think this one's about midway, and then this is sort of the current design. But yeah, you can see sort of how it changes, which is quite fun. So you can see where you've learned things through fights and other things. Like if something breaks, you'll be like, okay, I'm not going to do that again. Pastor Blaze talk about handmade ones.
So obviously, computer-aided design is got a lot of benefits, as Robbie's just gone through. But it can be quite daunting. I mean, with obviously he said, "Oh, there we go. What is going on there?" Come on. It's only when I'm talking. Oh, come on. This is not fun.
Maybe just back out presentation. Just do it.
Yeah, you know what? I'm going to actually just try and... Oh, okay. I'm moving the mouse and it's fine. Weird. This is... Oh, the mouse is going now. This is... Yeah, interestingly, this is only coming up on the screen. Everybody who's watching this back on the screen recording won't see any of this, so they'll just think I'm, like, scared of ghosts or something. But yeah, as Robbie said, computer-aided design can be very good for sort of rapidly exploring the design space of a combat robot. You know, if you want to sort of try out one thing, try out another. But handmade or sort of handcrafted design can be almost better in a way for trying out different things really quickly. And also, it doesn't require the learning curve of computer-aided design, which can be quite steep. I mean, as Robbie said, we will be running the Fusion 360 tutorial, but if you didn't want to use that, like there are obviously a number of alternatives, OpenSCAD, FreeCAD, and I use Salome, all of which I think are pretty good, although I've had some issues with FreeCAD, but they're all quite a bit more complex than Fusion 360. So definitely it can be quite a time sink. So moving over to just sort of handmade designs can be really, really fun. And a number of you will have tried this out already. These two here are two from the Robo Rumble. I think you made one of them. You made this one.
No, I didn't
sorry.
make those.
That was yeah.
But I remember seeing them.
I'm terrible with faces, unfortunately, but these are pretty cool. And what's quite interesting here is you get to sort of see the level of variety you can do with like really simple stuff. I mean, just sticking some screwdrivers on that one, you know, you got to try different pokey weapons, which really, like, you can actually see down here you've got a sort of similar spike coming out of the bottom towards this more finished design. So those sorts of things can actually, you know, be really worthwhile experimenting with. Also, this pyramid here has paper edges, which you sort of think, it's probably cosmetic, and I think it was done for cosmetic reasons. But during a fight, it worked really well because it gets underneath the robots really well. So by exploring like that, you can really start to push sort of what works well. We also have this, just sort of separate to this, we have a GIF here from Fred's Robots, who has a tendency to build robots out of Lego. This is like, I mean, it sort of looks like it's going to fall apart, but really, I think that's actually after a fight against a spinner there. So it took like barely any damage, and was super quick, I believe, for it to lay out. A little bit longer on the.
Not quick to move.
Yeah, it was a little slow to move, but I do want to see another Lego robot at some point. That'd be great. Moving away from that sort of first prototyping, you can then come down and use cardboard to just like straight up help you. Here's Robbie trying to work out, I think, where a protector, some kind of guard's going to sit. And by cutting out cardboard, you could get a good eye for it, and then just take that cardboard and cut it directly out of the plastic and hot glue it on. And then finally, of course, you can just straight up finish a robot like this. I mean, because I can recycle, there is in his, what, 5th iteration? Don't know, very, very large number of iterations here, and it still regularly wins at events. So, you know, just because it's a can that's been literally bent with, like, pliers does not mean that it's going to not be good. And this is done quite a bit within the community, so that's always a good sign. Finally, if you really want to have a fun time and like not much effort, bodging something together. So these are robots that, in their own way, were absolutely fantastic to watch. This is, I think, Milky Boy. Oh, no, it was Advent originally. There's a rule that we did sort of skip over, is that generally if you're fighting in a proper event, you have to have the name of your robot on it. Because this is an Advent mouse, it's called Advent. That one actually competed at a national tournament. I don't think it did amazingly well, but it was very funny. Everybody loved it. We have Tyrant here. I don't know how it happened. Really, honestly, Luke and Robbie just turned up one day with it.
It's not mine.
Okay, it's not yours. I'm pretty sure it's about 2 or 3 different robots hot glued together.
Yeah, so it's a failed print of this robot, which is the yellow thing, and then he literally got a hacksaw and just cut out the centre, and then the grey printed bit was part of another robot he was trying to make, a drum spinner at the time, and then I think that weapon motor was from another robot, and then the bar it's got on it was from Life and Death. So yeah, it's just like loads of different robots, and the theme of Luke's robots tends to be duct taping the electronics on.
Yeah, so I mean, maybe not follow the duct taping rule, but I think this got put together in the space of about a day.
It would be like the day before the competition.
Yeah, and it was very fun to watch. Again, didn't make massive progress. But then we also have Milky Boy, perhaps the fan favourite of the Roboteers Society, long since dead, I think. And this is, I think in its first iteration, it was just the bottom half of a milk can with 2 motors hot glued onto it. Didn't do very well. And then the next time around, they turned up and they're like, "Oh yeah, here we go. We've got Milky Boy again." And we're like, "Oh, it's just Milky Boy." And they had this big piece of duct tape over the front, and they're like, "Oh yeah, it's just a milk bottle." Of course, what we failed to realise is that they put a spinning bar in the middle of it, and their opponents also failed to realise this. So when they put Milky Boy down and then revealed the mouth, things went from sort of 0 to like 100 very rapidly, and the robot got pretty destroyed. But yeah, this was hilarious and great for a number of reasons. But yeah, that's about it for that. So now finally, we're sort of getting on to Locomotion here. We'll just talk a bit about how you actually make the robot move, and then we'll get into some case studies. Oh, here we go again. Come on.
We are also at 9 o'clock now.
Okay, yeah, sorry.
Try reading the mouse.
Gone on a little... Okay, yeah, it's the mouse. So, wheels are obviously the main way that we tend to see locomotion happen in combat robots. Sort of 500 to 600 RPM is probably one of the sort of what you'd want to aim for your drive motor.
At 6 volts.
Oh yeah, at 6 volts. Yeah, make sure you read the voltage. If it's 500 and 600 RPM at 12 volts and you power at 6 volts, it's not going to move very fast. This is sort of recommended for wheels around 25 to 30 millimeter in diameter, which is a standard that you'll sort of see purchasable online. And there are obviously lots of different things you can do with this. Obviously, bigger wheels generally mean lower torque. It's a little bit harder to get going. But they can also get very fast. So you generally tend to have uncontrollable but a lot of speed. Lower wheels are higher torque but really slow. Wheels will be a weak point and people will go for them. So over here, Robbie's explicitly put 2 sets of wheels on Life and Death. So if it gets chipped away, then you'll always have at least 1 wheel still there. Tire making can be tricky, but a lot of people go for rubber bands, and that works quite well. We haven't really talked much about walking and shuffling. We probably won't here really, because it's kind of not done massively often. But when it is done, it can be very cool. So this is a shuffling mechanism put together by our last society president. That is glitchy. This sort of thing can work really well. This is generally what's employed in shufflers. If you want, you can make each leg move independently, but you'll be wasting like hundreds of hours in trying to getting that to work, when usually this kind of thing works The downside, of course, is you definitely get more weight, but usually it's quite easy for them to just let's see if I can get that to trigger. Probably it's quite often easy for them to just sort of get stuck upside down. Self-righting with walkers is historically difficult. So that's about it for the main presentations. We'll just go over some case studies. We're just going to look at life and death. Robbie will talk us through some of his design decisions. Then we'll go through Blanksy, and then Connor will just go. Just Connor will go through Dr. Flippy. We'll probably be a bit faster than we were hoping to be this way.
Cool. So yeah, life and death is my.
We'll also hand out robots for people to.
Life and death is my main robot. So like every other robot, it uses N20 drive motors. When we were talking about electronics, and you had like the robo pad, and you have things like dual motor controllers. This doesn't use that. This uses two separate controllers, one for each drive motor. It actually uses drive ESCs that you can use at higher weight classes like beta weight, so it's a bit overkill, but it's just what I have lying around. It's got a slightly bigger battery in, so it can run for longer in an event before I have to change it. Like we said before, it's got a brushless weapon motor. Then the bar is made out of 2mm titanium, grade 5. I used to use like stainless steel ones and things, they just sort of bent. So good material for making weapons. The body is printed out of ABS plastic. And then, actually, do you want to go to the slide?
Yeah.
So yeah, this is an older version, but you can see it sort of exploded. So it's made out of a few things. So yeah, like main thing is printed body, and then you've got things like the polycarbonate that I've just bent just to hold all the guts in it. And then you've got things like this skid that I've got, which basically just stops the weapon touching the floor when it's this way up. And then the tyres it uses are from nuts and bolts. So I didn't make those, I just bought them. That's that robot.
And then my definitely simpler, definitely lost more fights robot here, Blanksy, was a bit of an experiment in terms of sort of trying to defend against the bar spinners, particularly life and death. So I went for this. I primarily built it around the idea that all of the wheels would be protected inside. I wanted it to be quite punchy. I wanted it to basically look, move, and act like a brick. Maybe I went a little too far in that direction because it doesn't drive very fast and gets hit out of the arena very rapidly. But the wheels are massively protected. I actually think, not this one, this one I think is immediately after a fight, and it's just got like 0 scratches on it. And I went for this sort of experimental rubber bumper. So as Robbie mentioned earlier, it's got a TPU bumper, which is sort of soft or rubbery, which means it deforms. But then you can see these slots in the side that I've put pieces of tin can into, or like thick sort of beans cans. And that takes a lot of the impact from spinners and things. So it can really go quite a long time against spinners in the arena. And I've seen it like bounce off the walls and stuff, and it just sort of carries on going slowly along until something hits it into the pit. This is also a dual configuration robot, because I realized very quickly that having this would just mean I'd lose to every flipper in existence. So I went over to this configuration. Usually it has a piece of acetate on the bottom, but it hasn't had that a while, just to try and get it under things a little bit better. Inside, it's very simple. It's just 4 motors. These pairs are in parallel, I think. Oh, they might be... No, they're in parallel, not series. Oh, they might be... No, they're in parallel. Yeah, it would be bad if it was in series. And it's driven by a RoboPad, one of the old prototypes, which has got that massive capacitor stuck to it. But this was, very easy to put together. It's got these sort of 9 bolts to just hold it down. That's inset into the plastic, which makes it quite quick to take apart. I wouldn't put this many bolts in your robots though, because unscrewing 9 screws just to get the battery out and replace it. It's just a pain in the backside. But yeah, that's about it for Blank Seat. Now we'll have Connor talking about Dr. Flippy.
This is Dr. Flippy. This is what me and Kai, who you've probably seen in that, Kai did the CAD, I did a lot of the wiring, robot friends. So it's a... Come around it. Sorry, Fresh. So this is the main mechanism of it. It's a gear motor that spins around and then it's missing some of the gears, so the arm flips up when it gets to this point. And then there's usually a big spring going from here to here to pull the arm up, which means we can do stuff like make it do backflips because you can put a really powerful spring in it. It's also, if you look at that little white robot there, the servos in it are like 20 pounds each, and there's 2 of them. Whereas we can use a little 4-pound motor and get this like ridiculous flip because we've got a big spring in it. That's very fun. I don't really want to talk about the electronics because we've done that a bunch. But what I would like to show you is kind of how we got there. So this is the first robot I made. I ordered a bunch of parts, and yes, it's just a paracetamol box that I taped the motors to and then zip tied the wiring to, because I just wanted to make a thing go around. So I 3D printed these tires and then realized that they didn't have enough grip, so I just wrapped tape around it. It worked pretty well. I had fun driving it around for a while. I think that's when I was stuck at home over Christmas. And then this was kind of the first actual bot where we printed a chassis and like actual mounts for stuff. And then this is where Kai took over the CAD. You can see it gets way better. We've got an actual flipper arm, and there's the beginnings of like, this is where the elastic band at that point would go under here. This was a fun one. While developing it, we made it, put a really big spring in it, flipped it, and it just like shattered into 2 and flew. You can see this is my room at the time, which is a complete mess. This was where we were testing it, and this is where it landed. And of course, at the time, none of us were wearing safety glasses. So wear safety glasses. This is the lesson to learn from this. Done this, and then the next up, we did a more. It's way too big. If you compare this to all the other robots you're looking at, it's too tall and too flat and stuff. But this was a working robot, and it was really fun. But we're kind of working on the next revision of it now in time for the event next Saturday, which we'll talk about in a minute. And this is MC Flippy. He's reborn. So this was the first prototype that I printed yesterday. It's looking a lot smaller and like a real robot now. So yeah, I printed this yesterday, and already I basically sent Kai back with a big list of things that was wrong with it. So he's currently going to redo the CAD, I'll print it again, we'll see what happens. So this is what I want to show mostly is, we went from this literally a paracetamol box with stuff taped to it, to like a cool backflipping robot. So iteration is really important. Alright?
And just a question, how many years have you been in the society, Connor?
Does last year count?
Sort of has a half.
So half a year.
And there you go. You don't need lots of experience.
Yeah,
Just-
yeah. I only bought the electronics for Christmas. So 9 months, and also me and Kai kind of do it for like a week and then don't touch it for a month. So yeah.
So that about draws us to the end of this. We're going to quickly say about next week. Should we do that now? I think.
Yes. Okay. So next week, assuming we get a computer room, which isn't entirely confirmed yet, we're doing a CAD tutorial on Thursday. I think that's going to be 7 till 9, so it'll be a bit earlier and a bit longer. We'll probably do a break in the middle just to break it up a bit. But Kai's going to go through and sort of, if you see like the pot over there, the little, just a wedge on the front and motor mounts, I think Kai's going to basically talk you through how to design that, and everyone can kind of do it along. So if you've done Fusion before, you could do something more fun. If you haven't, we'll kind of guide you through it and be on hand. Then the Saturday after that, the 16th, we're doing an event. It's probably going to be similar to the Give It a Go event, but cooler. So it'll be show up and build a robot. if you haven't got a robot already. So we'll have the robot pads and building materials, and you put a thing together, and then we'll fight it in a tournament. If you have already built a proper Antweight, we'll also be running like a actual Antweight robot competition alongside it, because I want to put this against Dr. Flippy.
Yeah, so we'll be running essentially 2 competitions in parallel. So if you have a robot, or if you want to finish or build a robot before then, you know, I hear you're all desperately wanting to get up and go build a robot, not like
Even
get
if
up and get out of here.
Just a wedge with 2 wheels, like
yeah.
that's still, you could do quite well with it.
Yeah, so if you have a robot, you want to bring a robot, then do that. Also, if you don't, then turn up. We'll have the Bodgebot / RoboPad set up with cardboards for a little cardboard league, essentially. And there will be prizes, not like big prizes.
No, big prizes.
Like
mega prizes.
Okay, yeah.
You want to really sell mega prizes. Like whatever
Mega
you're imagining,
prizes.
think 10 times bigger.
Yeah. Like, you know,
And then
3
remember our
Haribos
budget.
instead of 1. But yeah, there'll be some small prizes for that, so, you know, that might incentivize you. You know, Robbie's definitely trying to make his robots work now. But that's about it from us. Well, I'd like to just end with these do's and don'ts, because I genuinely think these are some of the rules to live by if you're doing robot combat. First, make sure you iterate quickly. Like, it's really easy to get freakishly bored. I mean, you all know this expertly now, having just watched this presentation for an hour. But believe me, when there's like a half-finished robot sat on your desk for a year, like it's just sad. So make sure you iterate quickly. You know, if you don't know if something's going to work, print it, try it, slick it together, see if it works. Refining one design can be massively boring. Don't start too complicated. You know, try and start it small. As Connor's already said, just, you know, strap 2 motors to a ramp and just see how it can go. As soon as you start getting it moving, then you can start sort of working out what you're going to want to do. Obviously, make sure you have fun. Like, you know, robot building is fun, and if you're not having fun, then you build different robots or something. You know, I'm not going to say don't build robots.
Go play rugby or something.
Yeah. Do a different sport, but no. I genuinely think this sport is it can be amazing fun. I keep on saying sport as if I'm like trying to legitimize it or something, but that's just because too many people have come up to me calling it that. It's genuinely a massively fun thing to do, especially if you start iterating. So have fun, see if you can do it. You know, just see what you can do with the time you've got. It's great from that, and I believe Connor's added this one to the end here. So if you want to give that one.
So again, you'll see from what I was able to do was a paracetamol box with some wires on it. And then I brought in Kai to actually design a really cool thing. So it is a lot better if you can find someone to work with, even if it's just like someone to talk to about it. I think me and Kai sat for like 2 hours last night, and we were just chatting about this and like how we wanted to improve it. And now Kai's gone away and he'll like redo the CAD, and I've got wiring stuff to redo. So it is a lot more fun if you've got someone else to do it with. Would highly recommend Robot Friends.
So that's it. If there are any questions, now is the time to ask them. If you all want to like keel over and sleep, you can't do that here, but you can go home and do that. We'll be going to the pub afterwards. I think we're going to be checking out the doctor's orders to see whether or not it's okay.
And if not, we're going to like scooch on back down.
Yeah, interval was quite loud last time, so we're going to try and get a little bit more of a chill place. But yeah.
I think that's it. Any questions? You can talk to us.